Vary the concentration of A while keeping the concentration of B constant. Then we're going to vary the concentration of B while keeping the concentration of A constant. Rate equals the gradient of a concentration time graph at time equals 0. Use a very large volume of B, which is an excess. B's concentration is changed, but the concentration of A is kept constant by using a very large volume, which is an excess of A. So what we're looking for here is to keep concentration of A the same, but change the concentration of B. So we're looking at experiments 1 and 2. Now we're doubling the concentration of B, and that quadruples the rate of reaction, so therefore it is to the power of 2. So it's second order with respect to B. Now we're looking to keep B the same, but we need to change A. So we're going to look at experiments 1 and 3. We're doubling the concentration of A, and that causes the rate of reaction to double. So therefore, it's going to be 2 to the power of 1. So it's going to be first order with respect to A. Rate equals K, concentration of A to the power of 1 times the concentration of B to the power of 2. Now you may want to pause the video until you've rearranged this for the value of K and worked out the units. So it's going to be mole per decimeter cube per second, that's for your rate. Cancel 1, combine those, bring them up to the top side. If the concentration of all reactants are doubled, then it's going to be 2 to the power of 1 times 2 to the power of 2, so the rate increases by 8 times. If we triple all concentrations of reactants, it's going to be 3 to the power of 1 times 3 to the power of 2 is going to be 27. So we're going to keep F the same and change E. So we're looking at experiments 1 and 2. We're multiplying that by 3, and the rate is increasing by 9 times, so therefore it's going to be 3 to the power of 2. So it's second order. Now we're going to look at experiments 2 and 3. We're doubling the concentration of E. Now as it's second order, that's going to make the initial rate go up by 4 times, making it 0.01512. Now for F, we are multiplying it by 0.5, or we could say dividing by 2. Then looking at the 0.01512 going down to 7.56 times 10 to the minus 3, we are multiplying by 0.5 or dividing by 2. So it's going to be to the power of 1. So it's first order. Now another way of doing it could be 2 to the power of 2 times the 0.5 to the power of y, or any other letter you want to use there, equals 2 times the rate. Now let's solve this. So it's going to be 4 times 0.5 to the power of y equals 2. So 0.5 to the power of y equals 0.5. So therefore y must be 1, which is first order. So you might find that an easier way of doing it. For D, we're going to look at experiments 1 and 2. Multiply that by 3, and the rate goes up by 9, so it's going to be second order. Now for E, we're going to look at experiments 2 and 3. Now let's see the effect of D on the rate first of all. So we're doubling the concentration of D, which will make the initial rate go up by 4 times. Now we're doubling the concentration of E, but there is no effect on the rate, so therefore it's going to be 0 order. Now the alternative method could be, so it's going to be 2 to the power of 2 times 2 to the power of y, or any other letter you want, equals, well, the rate goes up by 4. So let's solve it. So it's going to be 4 times 2 to the power of y equals 4. So it's going to be 2 to the power of y equals 1. So therefore, y must be 0 order. Now in this example, we already know that the bromate 5 ion is first order. Now we're going to look at experiments 1 and 2. We are doubling the concentration of H+. We see the rate goes up by 4, so it's got to be second order. Now for the Br-, we're going to look at experiments 1 and 3. Now you can see that the hydrogen ion concentration doesn't change. So we are tripling the BrO3- concentration, and it's first order, so your initial rate should triple, which gives us 1.008 times 10 to the minus 4. Now we're doubling the concentration of Br-, and the rate is doubling, so therefore it's got to be first order. Now alternatively, we could say 3 to the power of 1 times 2 to the power of y equals times 6. So 2 to the power of y equals 2, so y must be equal 1, which is first order with respect to Br-. So rate equals K, concentration of H+ squared, times the concentration of bromate 5 to the power of 1, times the concentration of Br- to the power of 1. Again, pause the video until you've worked out the units of the rate constant K. And there's your units.